Hello guys, welcome to Tough Math, a YouTube channel that features solutions to some math competition problems given in the past several years and given either locally or internationally. So our first problem, when a two-digit number is increased by 4, the sum of its digits is equal to half of the sum of the digits of the original number. How many possible values are there for such two-digit numbers? Okay, so we let this number n, and because it is a two-digit number, we can express it as 10 times a plus b, where a is the tens digit and b is the units digit. So this is the original number. Then when we increase it by 4, then we have, of course, n plus 4, which is equal to 10 a plus b plus 4, which is equal to 10 a plus b plus 4, which we can rewrite as 10x plus y for some integers x and y. Okay. Now, if b plus 4 is a single digit, number, then x is equal to a and y is greater than b. Hence, x plus y, which is the sum of the digits of the new number now, must be 1/2. No? However, x plus y, since x equals a, so you have a plus y. And since y is greater than b, then we have a plus y is greater than a plus b, which contradicts the condition that the sum of the new digits will be 1/2 of, or is equal to 1/2 of the sum of the original digits. So it must be that b plus 4 is a two-digit number. That is, it is greater than or at least equal to 10, but not greater than 20, of course. Is a two-digit number. Okay. That is b plus 4 is equal to 10 plus r, which is less than or equal to 9 plus 4, which is equal to 13. Therefore, B is equal to 6 plus r. 6 plus r, and this is less than or equal to 9. So this gives us r is either 0 or 1 or 2 or 3. Therefore, n plus 4 is equal to 10a plus b plus 4 equals 10a plus 6 plus r plus 4 equals 10a plus 1 plus r. Okay. So we must have a plus 1 plus r must be equal to 1/2 of a plus b, which gives us 2a plus 2 plus 2r equals a plus b. From which we get a is equal to b minus 2r plus 2. And from the following table, from the table below, we have first column is R, B, A. Second column, or the first row, are the values of R. So 0, 1, 2, 3. Okay. And then your B here is 6. For when R is 0, when R is 1, your B is 7. When R is 2, your B is 8. And when your R is 3, your B is 9. And correspondingly, when B is 6, A is 4. And then when B is 7, A is 3. When B is 8, A is 2. And when B is 9, A is 1. So you have A plus B is equal to 10, 10, 10, 10. And your A plus 1 plus R is half of 10. So 5, 5, 5, 5. This means that, okay, so from this, we conclude that there are 4 such numbers. There are 4 such two-digit numbers. Namely 19, 28, 37, and 46. Okay, so that's it for our first problem. Now we go to the second problem. 5 distinct positive integers are multiplied 2 at a time, yielding 10 products, the smallest of which is 28 and the largest is 240. Another product is 128. What is the sum of these 5 numbers? Okay. So let these numbers be A, B, C, D, and E. So A is less than B is less than C, because they are distinct and they are all positive. So C is less than D and D is less than E. Okay. Now the smallest is The smallest is 28. And this must be the product of A and B, because they are the two smallest numbers in the group. And the largest must be the product of the two largest values, which are D and E. So 240 must be DE, or D times E. Okay. Now, but there are many possibilities for 28. However, AB, which is equal to 28, can be the product of 1 and 28, or the product of 2 and 14, or 4 and 7. And DE, which is equal to 240, can be the product of many possible factors, the two largest of which are 15 and 16. So this can be 2 times 120, or maybe 4 times 60, or 6 times 40, or 8 times 30, and so on. There are many possibilities. However, etc. I will just write the two largest. Now, if E is equal to 80, or E equals 48, 16 times 3, 48, yes. Then x4, then x4 must be 3, or x sub 4 must be 5, which would imply that AB is less than 28. This is a contradiction. Hence, x sub 2 is not 14, or B is not 14. And B is not 28. It follows that x sub 1 is equal to 4, and x sub 2 must be equal to 7. Also, x sub 4 must be 15, and x sub not x sub 4 but D and E must be 16, which is equal to 2 to the 4. Since since 128 is equal to 2 to the 7, we must have another number having a factor 2, having the factor 2. Because x sub 1 is 2 squared. X sub 1, sorry, this is not x sub 1 but a. This one is a and this one is b. Okay, this one is not x sub 4. Sorry for this confusion. This is d, and this one is also d. Okay, we need another number having the factor 2 because a, which is 4, is 2 squared. Okay, this one is 2 squared. Two squared, and then a, which is 16, is 2 to the 4th. But 128 is 2 to the 7. So 2 to the 4 times 2 squared is just 2 to the 6. That's the reason why we need another number which has a factor 2. And that number is the middle number, which is C. Thus, we must have C, which must be equal to 8. Which is equal to 2 cubed. Thus, hence, A plus B plus C plus D plus E is equal to 4 plus 7 plus 8 plus 15 plus 16 equals 50. So this is our answer to the second problem. The sum of the 5 numbers is equal to 50. And then we have this challenge before we leave, as usual. It is given that 9 divides x, which is equal to 506 mn78. When x is divided by 8, the remainder is 2. Find the possible values of m and n. So challenge yourself. Try to solve this problem before watching the next video, which will show you the solution to this challenge. And think about this. If you are not willing to sacrifice something for what you want, then what you want becomes the sacrifice. The author of this statement is unknown, or the one who spoke about this is unknown. So that's it for this video. I hope you enjoyed our discussion. Thank you for watching, and I hope you learned something. Goodbye for now. Be well, and may God bless you all.